More than any system, the cardiovascular system has contributed strong imagery to people's daily language. The heart is a metaphor for love and courage. People say they nearly had a heart attack to describe an experience of surprise or shock. Abstract but distinctive characteristic qualities are said to be in one's blood. The functions of the cardiovascular system are all related to transportation. Nearly every substance made or used in the body is transported in the blood. The heart lies a little lateral to the left of the midline, between the lungs and just behind the sternum. It is divided into four chambers, which is the right atrium, right ventricle, and the left ventricle. The functions of the cardiovascular system are all related to transportation. Nearly every substance made or used in the body is transported. The atria usually contains the oxygenated blood, whereas the ventricles contain the unoxygenated blood. Between the chambers are valves that allow the blood to flow in the right direction.
Did you know that if you took all the blood vessels out of an average adult and laid them out in a single line, the line would stretch for over 60,000 miles long? And that can wrap around the Earth for approximately 2.5 times.
In real life, for example, an establishment has an entrance and exit. You can't go out through the entrance. One must exit through the right passage to avoid unnecessary collisions. Just the same with the valves. They serve as barricades during blood circulation. The entire structure of the heart is protected by a double-walled sac called pericardium. The circulation of blood in the body is made possible through the different passageways or the blood vessels. The arteries carry the blood away from the heart and are responsible for distributing nutrients, oxygen, and other biomolecules essential for metabolic processes. The smallest blood vessels are the capillaries, where the exchange of gases and metabolic waste are carried out. The region where the switch of substances takes place is called the capillary exchange. The blood consists of many different types of cells in a matrix called plasma. Plasma is about 92% water. The remaining 8% or so is made up of plasma proteins, salt ions, oxygen and carbon dioxide gases, nutrients from the foods you take in, urea, and other substances carried in the bloodstream such as hormones and enzymes. The most abundant in the blood are the red blood cells or the erythrocytes. The red blood cells are small flexible cells shaped like biconcave flattened discs with depressed centers on both sides. Because of their thin centers, they look like miniature donuts when viewed with a microscope. They contain hemoglobin, which is a biomolecule oxygen binds. Yourself injured and started bleeding. That just means you have just made an opening that can serve as a potential breeding ground for pathogenic organisms. This is where the white blood cells or the leukocytes come in handy. They serve as our body's natural defense mechanisms against potentially harmful microorganisms and thus prevent the further development of diseases. Okay, so let us go back to that injured area. Well, do you ever wonder how the bleeding stops? Platelets or thrombocytes are tiny pieces of cells and their job is to actually begin the clotting process and plug up the injured blood vessels. It is also notable that they have a short lifespan. They live for only about 10 days. Here's how platelets do it. First, there would be vasoconstriction of the blood vessels in order to restrict blood flow in the injured area, followed by platelets binding to exposed region. The platelets would then change in shape from smooth disc to multi-pseudopodal plugs and secrete cytoplasmic granules which would induce receptors that would now adhere to the fibrinogen and the injured region.